In this video, we're going to do an example of finding the zeros of a polynomial function. So we're going to find all roots. Remember, roots are just another word for zeros of the function f of x equals x to the fourth minus 3x cubed minus 6x squared minus 17x minus 15. So we're going to start by finding all the possible rational roots. Now, you watched the rational roots video, or the rational root theorem video, so you know that we can list out the possible rational roots by taking the factors of the constant term over the factors of the lead coefficient. Now, conveniently, this function has a lead coefficient that is 1. If the lead coefficient doesn't appear, remember you can always write a 1 and that is your coefficient. So it's factors of 15. Well, that's going to be 1, 3, 5, and 15. And like I said, the factors of the lead coefficient, well, that's just 1. Now remember, we need to take plus or minus every combination of the factors of the constant term over the factors of the lead coefficient. Fortunately, since the lead coefficient is 1, that makes this very simple. So the possible rational roots camera seems to be bouncing a little bit there. I hope that doesn't affect the video too much. The possible rational roots are plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Because we're putting each of these over 1, and of course dividing something by 1 doesn't change it. But we do need the positive and negative of each of these. Next, we want to check. Remember, these are just the possible rational roots. So if there are rational roots, they must appear in this list. You can have irrational roots or imaginary roots that don't appear in this list. Complex roots, even. But if a root is rational, then it appears in this list. So check to see if these are actually roots. And the way that we're going to do that is by using synthetic division. So I want to see if 1 is a root. If 1 is a root, then x minus 1 is a factor. And so dividing by, whoops, let me write this down. All right. So if 1 is a root, then this synthetic division will give me a remainder of 0. Or, well, this division will give me a remainder of 0. And I'm just using the synthetic form to make it faster. So I bring down the 1. 1 times 1 is 1. Negative 3 plus 1 is negative 2. 1 times negative 2 is negative 2. Negative 6 plus negative 2 is negative 8. 1 times negative 8 is negative 8. Negative 17 minus 8 is negative 25. 1 times negative 25 is negative 25, and negative 15 plus negative 25 is negative 40. So this remainder is not 0, and so positive 1 is not a root. And again, I know that because this remainder is not 0. So I'm going to use this space here. I've gone to using half sheets of paper so I don't accidentally go off camera when I'm writing. Hopefully that will help. I'm going to rewrite the coefficients of my polynomial. Now I'm going to test negative 1. So I bring down the 1 again. Negative 1 times 1 is negative 1. Negative 3 plus negative 1 is negative 4. Negative 1 times negative 4 is positive 4. Negative 6 plus 4 is negative 2. Negative 2 plus, negative 1 times negative 2 is positive 2. Negative 17 plus 2 is negative 15. Negative 1 times negative 15 is positive 15. And I do get a remainder of 0 here. Negative 1 is a root. I'll just underline everything. Negative 1 is a root. Hooray, we found a root. And remember, root is just another word for 0. So, I'm going to go to the next page. Since negative 1 is a root, x plus 1, which is x minus negative 1, is a factor of f of x. And I can get the other factor as the result of my division. Remember, this last number represents the remainder, and this is the coefficient, or the list of coefficients of my result of my division. So, we had the original polynomial was x to the 4th minus 3x cubed minus 6x squared minus 17x minus 15. And that factors, like I said, we know x plus 1 is a factor. And we can get the other factor by looking at this list of coefficients. So this is a constant term, this is an x term, this is an x squared term, and so this is an x cubed term. So I've got x cubed minus 4x squared minus 2x minus 15. And of course that represents the remainder, which is what makes this divide evenly. Now, I do need to find the other roots. I can do that by, instead of using the list of the coefficients from the original function, I found one of the roots, so I've got this factored a little bit. Really, I'm looking to factor this list. So now I can just give myself a slightly smaller problem and use these coefficients. So I'm trying to factor this polynomial, and this is the list of coefficients of that polynomial. Now, if one were a root of this, it would have been a root of the larger polynomial. So I'm going to go ahead and skip ahead. Notice that I still have 15 as my constant term. Sometimes will give you a smaller constant term if I had something other than 1. But I'm going to now check and see if 3 is a root of this polynomial, of this smaller one. If it's a root of this factor, then x minus 3 is a factor of this, so x minus 3 would be a factor of the entire polynomial, so 3 would be a root of the entire polynomial. So now I'm going to do the synthetic division. I start by bringing down my 1. 3 times 1 is 3. Negative 4 plus 3 is negative 1. 3 times negative 1 is negative 3. Negative 2 plus negative 3 is negative 5. 3 times negative 5, well, that's negative 15. And unfortunately, the signs are not opposite, so it's not 0. It's a negative 30. So this tells me 3 is not a root. Then I'm going to go ahead and just move on. Since 3 is not a root, I'll go ahead and try negative 3. I bring down the 1, multiply. I get a negative 7. Multiply here. Add negative 2 to 21. I get 19. This will give me negative 57. And really, it doesn't matter exactly what number this is. It happens to be, what, a negative 72? But the fact is, it's not 0. Negative 3 is not a root. So let's move on. Our next possibility is 5. So I bring down the 1. 5 times 1 is 5. That will give me a 1. 5 times 1 again is 5. Negative 2 plus 5 is 3. 5 times 3 is positive 15. When I add these together, I do get 0. So 5 is a root. Hooray, we found another root. So x minus 5 is a factor of, remember we were doing using this polynomial, so it's a factor of x cubed minus 4x squared minus 2x minus 15. Now that is not our original polynomial, but remember our original polynomial, which is written here, was equal to x plus 1 times this polynomial. So f of x will be equal to x plus 1 times whatever this is factored, which will be x minus 5 times, now remember we're going to use this, the 0 was the remainder, this is the constant term, this is the x term, and this is the x squared term. So this is x squared plus x plus 3. Let's start a new page. And so f of x is equal to, our original f of x was x to the 4th minus 3x cubed minus 6x squared minus 17x minus 15. Remember, we found that x plus 1 was a factor, and Really copying this from the previous page. And now we have this factored a little better. This second factor can be factored as x minus 5 times x squared plus x plus 3. Now remember, we're looking for roots here. We're looking for the zeros. Roots and zeros are the same thing. I do want to emphasize that. We've got a root of -1 from this factor, +5 from this factor, and then we have this quadratic factor. If I could factor this nicely, I would, but unfortunately I can't factor that. There are no factors of 3 that add up to 1. But it's quadratic, which means I can use the quadratic formula. So let's make I'll change color and make a little note to the side. Recall the quadratic formula. That's if I have a quadratic equation in standard form, which is ax squared plus bx plus c, then the roots of that are x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to use that on this, and I'll just pull out my quadratic factor here. So a is 1, b is 1, and c is 3. So my roots, my zeros here, -1, since b is 1, plus or minus the square root of 1 squared, which is 1, minus 4 times 1 times 3, all over 2 times 1. Of course, 4 times 1 times 3 is 12. 1 minus 12 is -11. So this is 1 plus or minus the square root of -11 all over 2. Now I've got the square root of a negative number, which means this is imaginary. And so that is -1 plus or minus I times the square root of 11 over 2. These are the roots of this factor. So these are also roots of the original function. So the roots of f of x equals x to the 4th minus 3x cubed minus 6x squared minus 17x minus 15 are, we've got these roots here, -1 plus or minus I times the square root of 11 over 2. Notice that this has a plus or minus in it, so this is two different roots, just written in this nice compact form. It's -1 plus I root 11 all over 2, and -1 minus I root 11 over 2, those two separate numbers. My other two roots, remember from this factor we had a root of -1, and from this factor we had a root of +5. So there are the 4 roots of this 4th degree polynomial.